I'm Matt from Fortress. Today we're at Tata Steel where we're going to see some of the different parts of the Zodiac line. We'll see different Fortress solutions that Tata have used to address some different challenges across this process. I'm joined by Gareth, who's going to kindly walk us through some of the challenges Tata have faced and how those have been addressed across these different applications.
Yeah, so I'll walk you right through the line from the entry to the exit section, just showing you all of the Fortress products that we've got on the line from all the way back from 20 plus years ago to current products that we've installed in the last year. So you can see everything that we've tried to use here and how we're continuing to develop. We're using Fortress products to improve our safety on the line as well. So Tata Steel was Zodiac plant in Lambourne for a lot of different challenges that we face here. A lot of machine safety, so a lot of things that are dangerous on the plant. We want to stop human interaction, and also just general access into areas is becoming more and more important, and competent, correct people going into the right areas of the plant, which is really important as well. So we've tried to bring that on over the years, and then also the general regulations, safety regulation, basically meant that we've had to bring along the safety level at the plant as well. We've used a lot of Fortress products to achieve that because they will be required.
Well, again, thank you for having us. We can see we've got steel rolls being moved behind us, so
yeah,
we're right at the beginning of this part of the process now. I guess if you could talk us through a little bit of what we'll be walking through as part of this.
So this is the end section where they bring the coils into the line, and then they feed them on the line in the right order, and then they come through this end section. Then go further down, they'll get welded. They weld the tail end of the previous coil to the head end of the next coil here. So we've got a number of machines, mainly our welding machine. Again, it's got a number of, I suppose, legacy Fortress products on there. So just general interlock gates.
So here in this area, these devices are used to control access to this part of the machine for some of those minor interventions or whatever.
Yeah, so they have to go into this machine fairly regularly, so those interlocks, they got to do things like they got to change weld wheels, take scrap cuts out of there on a fairly regular basis, maybe every hour or two on the line, fairly regular to go to standard shift.
So now we've moved down the process. So yeah, Gareth, you can tell us a little bit more about what's going on.
Yeah. So we're in our entry looper section now, basically where the strips held in this fold base. So we've got some number of Fortress items here. So we've got some standard kind of interlocks which we use for accessing the line on down periods or light stop. We use this basically to allow us access to sliding gates up on the level above, because again on down periods we need to go in and do maintenance, etc. So we used to have some fairly old, damaged access gates, just bolted fences which used to get damaged and really wasn't keeping the integrity of the line safe. So we upgraded a few years back, put in this key trap system. So this now is linked into the e-stop for the line. So if we want access, it'll interlock the line. But then we got multiple keys then for access, numerous sliding gates on both sides of the looper, so it allows us to go in and carry out maintenance, and we don't have anywhere near the same problems now with damaged guarding, people not bolting guarding back, because it's a good easy access system which is safe.
Brilliant. Fantastic. Yeah, that sounds like a great example of trap key. So by turning that first key, triggering that stop, that then allows the release of these other keys, and then mechanically those are linked to interlock devices on those different levels.
Yes.
As you said, that prevent people from leaving those guards open or not following that sequence correctly.
Yeah, exactly. Yeah. I think like some examples like that are useful for us as well, because some areas are not easy to get cable into.
Yeah.
So that type of solution is quite useful in some areas where it's not always easy to cable to certain parts of the plant. So that type of system is quite good for us in some parts of the plant as well.
So here we can see how the crank system allows not only the control of access into the area, but also the management of that authorization. Who has the permission, who has that gas awareness training in this case, in order to perform those tasks. Previously, there was a less controlled process about who to retrieve those gas monitors and who'd have that gas awareness training before they enter these areas. Now, through the use of RFID access control, we make sure that the authorization of those permissions prevent people who aren't authorized to access these areas. It's only the people who performed that training that will be able to have access granted and go inside that space.
We put the system in twice, basically, so the same as we've got, so we can turn that key stop,
Yes.
and then we go about to the keys which access those sections.
So when that key initiates the stop with the machine, it's taken to that exchange, which can then allow access to different hatches or access points to the gas system. You can see here we've got an Amgar probe unit where that access key needs to be entered. But then before you can open that device, you have to take out that personnel key. So that extracted personnel key, that's then taken by that operator or potentially someone as they enter that space and perform that task. It's exciting to see how all the things we've seen as part of that process, as you said, might end up in our cars, might end up in the buildings that we walk past or walk into every day.
Yeah.
So yeah, it's great to see this as part of the process. Could you walk us through a little bit of what those access requirements are for this part of the inspection?
So there's some access gates here and above which actually allow which actually stop the strip for the inspector. So on some products, sometimes they need to go in and they actually contact the strip with those stone the strip to see if a defect is showing through, so they can look at it on the live strip in front of them if required, and then they close it and they can start the exit again, so they can interact with the strip a little bit in these places if they want. So it's not a straight e-stop of the line, it actually allows them access into that area, so because there is some requirements to check that strip as well.
Brilliant. It's really interesting to see, I guess, the variety of different access conditions or requirements you have across the process. Mm-hmm. Sometimes we have that mechanical separation where you're trying to enforce a sequence over quite a big area or quite a few different levels. Yeah. Sometimes you've got, I guess, the emphasis on that authorization of training.
Yeah.
To examples like this where you've got, I guess, maybe a slightly simpler example of when you open that interlocked guards, then you trigger a condition within the system.
So today we've seen a range of applications at Tata Steel Llangwen. We've seen the bonding together of those steel rolls, the accumulator, furnace and inspection process as well. We've seen how Fortress has helped Tata Steel over a number of years with a range of challenges and solutions, whether that's more traditional access control or enforcing processes or sequences over larger distances or periods. We've also seen the use of enforcing permissions as part of that access as well. Thank you very much for watching this Fortress case study. If you'd like to find out more, please visit our website or contact us for more information.